Alright, so here we are, trying to put aside anything that's not math and get back focused on math. So Jade reminded me that we didn't finish something yesterday. So Jade, show me what that is. Okay. So we're doing this practice sheet that we started yesterday, and we have 2 problems left. So here are the 2 problems we have left from it. Two of those though. Alright, so this is what we still had left to do from that Precal practice paper that we started yesterday. We did it all except the last 2 problems. So these are the last 2 problems. So this direction says solve triangle ABC. So what does it mean to solve a triangle? Find everything you don't already know. So what do I not already know? I don't know this side, but I do know these 2. It's a right triangle, so that should be pretty easy to find, right? Right? Yeah, how would I find that? Pythagorean theorem. So a squared plus 100 is 144. So a squared is 44. A is the square root of 44, which is what? No, yeah, I want to simplify the radical.
6.633.
2 root 11.
Thank you.
I'm so sorry.
Okay. Now, what else am I missing?
The angles.
I'm missing all of the, oh no, I'm missing the 2 acute angles. So it doesn't matter. Let's go ahead and just do B first. It makes no difference at all. How could I find angle B?
I don't know, sine.
I could use sine. If I did sine, it would say sine B equals 10 over 12. So what would I type into my calculator to get angle B then? Second sine. If you want an angle, you're using that button right there every time. So second sine, 10 divided by 12, I got 56.44. And then the other one will be a no-brainer because that's 90. These 2 have to add up to the other 90. So that would be 33.56. Triangle solved. Now, all of those word problems were just like this, except instead of having to find everything, you would just ask one question. You know, what's the angle of elevation? How tall is the building? You know? So you've been solving triangles all along. You just haven't necessarily been finding all the pieces like this time. All right, we want arc length down here.
Oh, you need to put the 100.
Yeah, we got an issue. That's a degree measure, right? So I know I'm going to do radius times radians. So I know I'm going to use 10. And now I need the radian measure for 100. So pi is to 180, as something is to 100.
10 pi over 18.
So I have 100 pi over 180, which is 5 pi over 9. That's not the answer. Don't get carried away and write that down as the answer. That's just the radian measure. So now we can multiply that, and it looks like that arc length is 50 pi over 9. got this one, which was the same picture but a different unknown. This time I'm looking for the radius, but I will use the same formula, of course. So 9 equals the radius times a half. So divide by half or multiply by 2, and the radius is 18.
How do you know 1/2 is in radians?
Because there's no degree mark on it. If there's no degree mark on it, it's a radian measurement. Radians are used so commonly that no mark is made. People just know it's a radian measurement. All right. So what else
Under review,
have we found that we need to do?
number 17.
Number 17. Which one?
Let's go ahead and do that, I guess.
All right. So A says sin x equals negative root 3 over 2. So I need to figure out what x is so that the sine is negative root 3 over 2. Now, this is really important because that tells me that I am looking where?
The whole circle.
The whole circle. I am looking for answers everywhere. All the way around. I'm to find all of the angles all the way around that would make this true. So where could those angles be? Could they be in all 4 quadrants? Could I have an angle in quadrant 1 that would make that true? No.
It'd just be the third and fourth.
It'd be the 3rd and the 4th, because sine is y, and that's where y is negative. I need a negative y value. So that when I label this, it's negative root 3 over 2. Sine is opposite over hypotenuse. That makes perfectly good sense. And this side would be negative 1. So how big is that angle right there?
60.
60. And this one's 60, because when you have multiple solutions to a problem, you have multiple triangles. When you draw multiple triangles, they're all congruent to each other. So if that's a 60, that's going to be a 60.
So do we need to write the 2 different angles then?
You're going to write down 2 answers, Brenton. Just calm down. Let me finish the question. There are going to be 2 answers to this question. One from each quadrant, but it's not 60. 60 is not an answer. This would be an answer. So what is that? X is what? 240. And this would be an answer, which is 300. So those are the 2 answers to the question. Mallory?
Why does the one in the 3rd quadrant count again?
Why would we count first?
Because it's just negative root 3 over 2.
Okay.
It's a sine problem.
Okay, wait. Is that notation in the problem? That's the notation that has the rules.
Okay.
That is not in this problem, so you're not even thinking about that.
Okay.
Your beady little eyes are focused right here. Those are the directions. That says look everywhere. Right? Yes. There's a difference between both problems we're finding angles, so that is in common. But where you're looking for the angles is different. Okay?
Can we do one of 18 as well?
18
We can just do that.
says solve with a calculator. So problem A,
Oh, never mind. It says with calculator.
yeah, problem A is exactly the same, except that angle's not going to turn out to be special like that. This is going to say the sine is negative 1/3. Now, negative 1/3, I mean, the sine's negative. That's here and here. But negative 1/3 is not an angle that I can recognize, right? right? Don't have it memorized. So I need to go to my calculator and figure out what that angle is. So what button do I press to get me an angle?
Second sign.
Second sign. Now I never put the negative in. I've already handled the negative by drawing it in quadrants 3 and 4. With a sine problem, it really isn't going to make a difference. With a cosine problem, it's going to be confusing. So try not to put the negative in. You just want to know, well, how big that angle is. So I got 19.47. However, that is not going to be an answer. What is going to be the answer to the question? Well, these are both 19.47.
Oh,
So that one would be
199.
199.47. And that one would be 340.53, but double check that and see if that's right. That second one? Yeah. Now, I have answered that in degrees. I could have answered that in radians if I had been expected to. And I say that because the directions are in radians. The only change I have to make is I need to go back to mode and set my calculator in radians. And then, and then when I second sign 1/3, I did about 0.34. Get this angle to be 0.34. So I didn't press anything different, didn't do anything different. Just set it in radians. And then to find 0.34 is not an answer. I still need this angle right here. How would I find that angle now if I'm in radians? Before you added 180, you're not going to be adding 180, you're going to be adding what? Pi. So one of your answers is going to be pi plus 0.34, which...
Couldn't you just mark it as 1.34 times pi? Would that also work? Or?
Is 3.48. What did you say?
Would you be able to put it as 1.34 pi?
No, because there's no pi on this. That's just a decimal.
Okay.
That's not 0.34 pi. If it were, you could, but it's not. And then how are we going to get the second one then all the way around?
Because it's just the, that's just
Exactly, you
the
would.
angle.
And for those people that are like, what? How did you get this one? 360 minus 19? So if you're in radians, you're not using 360, you're using 2 pi. So it's 2 pi minus 0.34, which would be, oops, that was supposed to be 2 pi minus 0.34, 5.94. So in radians, those would be the two answers. And that's done exactly the same way if you're in degrees. You're just not using pi, or you're not using 180 and 360. You're using pi and 2 pi, and you have your calculator set in radians.
You have two triangles.
You have to put degrees and radians in?
No.
You can just put one.
Well, you put whatever one the directions say, and these directions were in radians. So the radian answers are the actual correct answers. Brenton?
How's 3.48?
This is about 3.14.
Oh, you just, okay, you had it.
Yeah. All right. So what else do we have? We have a test tomorrow. Cassie,
Number 5.
the same review sheet we've been on?
Yeah.
Number 5. Find the value of all 6 trig functions for an angle whose terminal side contains the point -3,1. Plot the point -3,1, make a triangle, and then just start filling in the numbers. So the point -3,1 is over here. The hypotenuse would be the square root of 10 by the Pythagorean theorem. Now I want, Cassie, do I need to do this? Find sine, cosine, tan, all those, using that triangle. Rationalizing when necessary. So when I do cosine, for example, it's going to be -3 over root 10, which is -3 root 10 over 10. And so on for all 6 functions. All right, what else? All right, I'm gonna throw some random problems at you. Let's see how we do. All right, so here's the first one. This will be an easy one. We'll warm up with an easy one. What's the period? Alright, so what do? We gotta find the period. What do?
Take the period of
So we find the period of each piece. So what would the period of this piece be? 2 pi divided by 1/4, which is 8 pi. So we've got 8, 16, 24, 32, and so on. All right, what's the period of this piece? 2 pi over 3. Oh boy. So we have 2 pi over 3, 4 pi, 6 pi, 8, 10, 12, 14, 16, 18. I'm getting lazier as I go down the line. These are all over 3. And they're all pi's. You get that? So this last one down here that I stopped at is 24 pi over 3 because what's 24 pi over 3? 8 pi. So the answer to the question would be 8 pi. Is that sinusoidal?
No.
Absolutely not, because these two are not the same. All right, next random question. No calculator. All right, no calculator. What's this say? Find the tangent of the angle whose cosecant is 5/4, right? So what am I going to do first? I'm not going to deal with cosecant. I can't deal with cosecant. I don't have any rules for cosecant. So I got to think about this as the angle whose sine is 4/5. Is that true? Now that I can deal with. Where is this picture going to be? Where is that angle? The first quadrant. Technically, it could be 1 or 4, but since it's positive, it has to be 1. The sine is 4/5, right? Which makes 25 minus 16 is 9, so this is 3. And the answer to the question is? 4/3. Now, let's make sure we can type that into our calculator if we have to. So we type this in. You cannot type this in because you don't have that button. So you're going to have to rewrite it like this, even on your calculator. So tangent, second sine, did you get 1.33333? Yep. Which is the same as 4/3. So we type that in and... All right, how about this one? Tangent of x is 5/6. Find the sine. think you all have pretty handily. That just means I'm gonna draw some kind of triangle, and opposite over adjacent will be 5/6. What does that mean? That's where the triangle is gonna be drawn. Because what does that tell me? I'm gonna draw my angle between what and what? It's gonna be in the third quadrant, because it's gonna be between 180 and 270. So that tells me where I draw my triangle. So there's my triangle. Now I'm gonna have opposite over adjacent be 5/6, but I'm gonna be real careful, those are both negative, which is gonna matter. And then my hypotenuse will be the square root of 61, root 61. Slightly. Now I want the sign. So the sign would be -5 over root 61, or -5 root 61 over 61. All right. Here's another one. What in the world is the equation of that curve? And there's more than one possible answer.
So like, you wanna write out like the little spaces with the tan, real quick?
We can. Now, I'm not gonna put a blank in front, because one of the things we know about the tangent is there is no amplitude. Now, the only reason there would be a need for that blank is if you had to put a negative, if something were upside down. But there isn't gonna be a number there. It's also gonna be virtually impossible to tell if there's been an upward shift, so I'm not gonna worry about that either.
Okay.
It's hard with just a picture drawn like that to see.
So
I didn't intend for it to have an upward shift. All right,
So negative,
this is negative. Why is that negative, Brenton?
because it's flipped.
It's flipped. It's upside down. Brenton knows that a regular tangent curve looks like this. That is upside down. What else is different about it? Besides it being upside down, it shifted. It is not, this dot is supposed to be at the origin. And the asymptotes are here for a regular tangent curve. What has happened, this dot has been shifted pi/2 to the right. So that will be x minus pi/2. Now what does that number control? That controls the period. Now, the normal period of a tangent and a cotangent is pi. That's the normal period. What's the period of this? That's asymptote to asymptote. What's the period of it? Pi. So guess what? We didn't change anything, right? So that number just is a 1, or not there. Now, anybody who memorized your sheet, memorize the graphs on the sheet, that is the cotangent. That's exactly what the cotangent looks like. No shifts involved at all. Is this a correct equation? Yes, this is fine. Way more work than we needed to do, but it is absolutely correct. Just like with the sine and the cosine, you can always, you got a shape like that, it could be a cotangent or a negative tangent. Just like a shape like this could be a tangent or a negative cotangent every time. Okay? All right. I have a lifeguard tower that is 15 feet tall. I am the lifeguard, so here I am, sitting right here at the top of this lifeguard tower. I am looking down at this little kid in the pool. Here's the kid in the pool. My angle of depression is 28 degrees. Where does that go?
Right by the K.
Right by the K. No, 28 degrees, right there. Because if I'm looking at him and he's looking at me, it's the same angle. The question is, how far am I from the kid? How far am I from the kid?
So you're gonna.
So where are we putting the X?
On the hypotenuse.
On the hypotenuse. Because there I am, and there the kid is. Now, if the question said, how far is the kid from the edge of the pool? That would be here, right? All right, then you look at it, what function are you gonna use? Sine. You're gonna say sine 28 equals 15 over x. You clear your fraction just like we always do, and then divide. Now, I don't know, I messed around with my calculator. Before I type that in, I'm gonna make sure I'm in degrees, because that was in degrees. So if I'm inputting degrees, I need to be in degrees.
On the review, on number 26, 3, it asks for direction.
That would be, well, let's just see if we can draw that there real quick. Due north, and so here's port, I'm going due north. 12 knots for 2 hours, that's 24 nautical miles. Knots, remember, is nautical miles per hour. So it's a speed. I'm going 12 miles an hour for 2 hours, that's 24. Then I turn on a course due west. Right, that's nice, because it's due west. Speed of 13 knots for 1 hour, so that's only going to be a 13. So I went north 24, west 13, and then I went the distance and the direction from the port. So remember, this was the port. So the distance will be a Pythagorean theorem problem, that'll be easy. The direction is this angle right here. Remember, if you are giving directional angles, they're measured from due north clockwise. So in order to figure out what that is, I'm probably going to want to find this first. So if I call that x, the tangent of x would be 13/24.
I think it's like 28.
So it's 28 degrees, I'll just say, let's say it's 28 degrees. Then the actual direction would not be 28 degrees. The actual direction would be what? 360 minus 28 degrees, because it's all the way around except for that little angle there.
Okay. And then would you put, like, with this going northwest?
No, you don't, if you give a degree measure, that's it. That tells me it's going northwest. Anything between 270 and 360 is going to be in the northwest quadrant.
Okay.
That's why we have a uniform, way of naming the angles. All right, so tomorrow is testing. Make sure you have a calculator. Make sure it's got batteries.